Alright, it's time to do many chain rule problems in this video. And here I have what we're working with chain rule. H prime of x, or given that h of x is equal to f of g of x, the derivative, or h prime, is given by this formula. The derivative of f, keeping g the same, times g prime of x. And this is what we're going to be doing. And also, in addition, everything that we learned in the past, such as product, quotient, product, I already said product, power rule, all those will be fair game. And also trigonometric functions, there will be examples of that. So all those I'm going to be using in these problems. And another thing I want to say is that this is kind of a improvised session, meaning that this is the very first time I'm looking at these problems. So you'll see exactly what I'm looking at and how I approach certain problems, and maybe you can take away something from this video, like how I approach these problems and my organization strategy with these problems, and maybe you can apply them to your own work. So let's begin with the first question. Wrong. 1. I want to find the derivative of this function. There we go. So this is our very first one. So let me zoom out like a lot more. There we go. Derivative of f. So I see the first thing I notice is that it is a composition of functions, and how I know that is I see this is the inside and the outside is the whole thing raised to the 4th power, and that's the key part of the chain rule. And there has to be something inside and something outside. And the way I like to do it is I like to say the inside, or g of x, is, and then I write out what the inside is. The outside, I like to write what the outside is, which is something raised to the 4th power, or x to the 4th power, right? So now, I want to find the derivatives of each part. So, the derivative of g is, using the power rule, we get 12x plus 7, and using the derivative for f of x, we get 4x cubed. And I guess the next part is to fill it into the formula. So the formula says f prime of g of x multiplied by g prime of x gives the derivative formula. So the way to, I guess, plug everything in is we look at, this is the input we're putting, so we're basically putting this function into the x, or anywhere we see x, into the f prime formula. So it's going to be the derivative, so I'll say the derivative of this is equal to 4, and then we want to plug in g, 6x squared plus 7x cubed, you can't forget the cubed, and then we multiply by that chain, which is 12x plus 7, and we're done. So as you can see, the way I approach these problems is by, I guess, taking it very organizationally, if that's a word. I find what the inside is, what the outside is. I find 4 pieces of information, which is the inside, the outside, the derivative of the inside, and the derivative of the outside, and with all these 4 pieces of information, I'm able to simply plug it in here into this derivative formula, which is the chain rule. So remember, you want to keep g the same when it's inside f prime, and then multiply by g prime at the very end. So that's exactly what I did here, and I don't have to simplify here because I know, it's correct, so there's no need to try simplifying and making an error in simplification when you already have the correct answer. So I'm just not going to simplify because I know it's the correct answer, and I don't want to make a mistake trying to simplify it. So let's continue. Question 2. I want to find, given y is 4x squared minus 3x plus 2, all raised to the minus 2 power. And I guess from this point on, if you feel like you can speed up ahead of me, I encourage you to do so, because I'm going to take it in an approach that is very slow, like what I did with the last one. And if you feel like you can race ahead, you can, and then just skip to the next one once you feel like, or skip to the answer, and then you'll see if you got it right. But I'm going to work through it, the whole process through, meaning finding all 4 parts, writing the formula, and filling in the formula. So Oops, did not mean to scroll. We're back. There we go. The inside is this, so 4x squared minus 3x plus 2. And the outside is something raised to the minus 2 power. So that's what the inside and that's what the outside is. This is the outside. And then the inside derivative is 8x minus 3. And I just used the power rule there. And then I'm also using the power rule here. Minus 2x and then minus 2 minus 1 is minus 3. So now I want to fill it into the formula. F of g prime of x times g prime of x. I wrote it wrong. It should be f prime of g of x times g prime of x. So let's see. Now let's fill it in. Filling it in. What do we get? You get minus 2 of the something, which is g, 4x squared minus 3x plus 2. And then we can't forget the minus 3. And then we multiply by 8x minus 3. And we are done. Yeah, we are done here. And this is the answer. And again, I'm not going to simplify it because I'm going to make a mistake if I even try to simplify it. And that wouldn't be good, especially on a test when your answer is wrong, but you had the correct answer somewhere. So from here you can just say you're done, especially on something like the AP exam. You can actually say you're done here, and it's still correct. You don't have to simplify it. Number 3. Y is equal to the cube root of 1 minus 8x. And here we go. This is a complicating looking function because a cube root, we don't really see cube root or square roots that much, especially because it's the chain rule. So again, if you feel like you can go faster than I am, I encourage you to do so because I'm going really slow, and I know I'm going really slow, but that's the purpose of what I'm trying to do. And if you feel like you can get the answer faster than me, then go ahead and then check the answer and then go to the next problem. Okay, so here I'm going to employ a strategy. I'm going to rewrite it because I don't really know. In my mind it's kind of hard to see cube root and then using the chain rule. So I'm going to write it like this, using a fractional power. And it looks more like a power rule example with a chain rule, right? The chain rule and the outside's like a thing we've seen before. Inside's here, outside something raised to the 1/3 power. So again, g of x is equal to 1 minus 8x, and f of x is equal to something raised to the 1/3 power. So that means g prime of x using the power rule is minus 8, and f prime of x is equal to, let's see, we hop down the power, 1/3, we subtract 1, which is minus 2/3. And then like always, we fill it into the formula. F prime of g of x times g prime of x. And what do we get? We get 1/3, and then we fill in g of x, 1 minus 8x, raised to the minus 2/3 power times minus 8. And I'm not simplifying here because I already have the correct answer. That's the correct answer. There we go. Continuing on, number 4. We have this function that is going to be 2 sine 3x plus tangent of x. Let me write this more clearly. There we go. And I want to find the derivative of this. So again, what's the inside? What's the outside? So the inside here is this thing, and the outside here is this thing. So let's do it. G of x is given by 3x plus tangent of x. I'm just going to write it like this, tangent of x. F is given by 2 sine of x. And we know how to find the derivatives of these parts. So the derivative of the inside is 3 plus the derivative of tangent is secant squared. And then we look at the derivative of f, 2 sine, so it's pull the constant out and then find the derivative of sine, which is cosine. And now we just fill it into that formula, right? I'm going to write it every single time just to remind everyone what this formula says. And now I just fill it in. So 2 cosine of the inside, which is 3x plus tangent of x. There we go. Times the derivative of the outside, which is 3 plus secant squared of x. Right? And let me just double check this. Yeah, it looks about right. Yeah, that's right. So this is the answer. Ta-da! Let's move on to number 4. I mean, not number 4, number 5. Number 5 says f of x is equal to cosecant of 7w. F of x equals cosecant of w. So here we go. Derivative of the inside is that, or I mean that's the inside function I should say, and this is the outside. So g of x is 7w, and f of x is cosecant of something. The derivative of g, or the inside function, is the 7, and the derivative of f, you have to remember this one's a trigonometric one, is negative cosecant x cotangent of x, right? And this x appears twice, that's something to notice, that's what I noticed. So that means anytime there's an x, I have to fill it in with whatever the inside is. So derivative, the chain rule says this. So now I fill it in. F prime is negative cosecant of x, which is 7w, or the input, which is basically we have to fill in this here and this here. And then it's cotangent 7w. So that's that first part. Now we have to multiply by that chain, which is the 7, and that's it. Again, not too difficult once you get the hang of it. You're just doing basically the same thing over and over again, just with different functions and different combinations of functions. Let's continue with this and look at question 6. Question 6 says y is equal to tangent of 4 plus 10x. Okay, how do we go about this one? Let's see. The inside here is this, and the outside here is that. That's the first thing I always like to point out. And maybe you'll, once you get used to it, you'll actually just know it immediately. And then you can just maybe even do the formula in your head once you get a lot of practice with this. So the derivative of g is equal to 4 plus tangent, or 10x. The derivative, or let's do the outside first. The outside is tangent x. So that means we can find the derivative of both, which is 10, and the derivative of the outside, which is secant squared. I feel like I just, no, never mind. So now we just go ahead and fill it into the formula once again. Maybe this is starting to be an annoying process. It is to me, because I'm writing this formula every single time and finding all 4 parts, but it's good practice. It's a good habit to have, just to write out everything. And it doesn't actually take long, it's just the effort of writing it actually feels long for some reason. We fill it in. X is, or in this case is g of x. Like that. And then we tack on the derivative of the inside. Okay. Now let's continue, and I'm going to, oh, I accidentally scrolled it down. Not good. Let me try to scroll it up. A little bit higher. There we go. And we're going to go for more problems. I had to take a cut here because whatever I'm recording on only allows up to 15 minutes, and I don't think I can fit another one in that 15-minute time frame. So question 7. Let's do y is equal to x plus square root of x to the minus 2. And let's try this out. So the inside, I'm going to go a little bit faster. The inside is x plus square root of x. So that means the derivative is 1 plus, if you don't know this one, it's this. And then the outside function is x to the minus 2. So that means the derivative of that is minus 2x to the minus 3. Now we just fill it into the formula. So it's the derivative of f. So I'll still keep on writing. I'm just going to go a little bit faster. So filling it in, it's minus 2 x plus square root of x minus 3 times the derivative of the outside, 1 plus 1 over 2 square root x, and we're done. So that's the derivative of this function. Continuing on to question 8. Question 8. Okay, it's this one. Y is equal to sine to the minus 5x minus cosine to the third, or cubed of x, and this is where we have to actually start rewriting it because it looks very confusing to know what the outside and the inside, so I'm going to rewrite it here. This is the same as sine x to the minus 5 minus cosine x to the third. So that's much easier to look at because now we can actually see what the inside is and their outside. So it's actually two chain rules that we're working with. And we can do that because there's just a subtraction sign that's in between them. So doing some sign, like the first term here, g of x is sine. So that means the derivative is cosine. And f is x to the minus 5, so that means the derivative of f is minus 5x to the minus 6. So this chain rule here is here, I'm just gonna write it from here, minus 5 sine x to the minus 6 times cosine of x, and then subtract the same thing here, right? The inside is cosine, so that means the derivative is negative sine. I'm running out of space on the right side. That's fine. F is x to the third, so that means the derivative of f is 3x squared. Now I just fill it in here. It is 3 cosine of x squared times the derivative of the inside, which is sine of x. And I'm still not going to simplify because it's too much work. So let's continue. Number 9. Number 9, let's do, okay, this one. X cubed 2x minus 5 raised to the 4th power. So this is a product, right? We have a product. We have this and we have this. And this one involves a chain rule, and this one's just a simple polynomial. So let me actually do it like this. There we go. So we have to use the product rule, and this is how I do the product rule, very similar to how I do a chain rule. I find the two functions or the two products. This is x cubed, and then this is 2x minus 5 raised to the 4th power. F prime of x is equal to 3x squared, and g prime is what we need the chain rule for, so this is some side work here. Side work. What's the derivative with respect to x of this? 2x minus 5 all raised to the 4th power. We have the inside function, and it's a derivative. And then we have the outside function, and it's a derivative here. And then we just fill it into the formula. It's 2x minus 5, 3 times the derivative, which is 2. And that's this right here. 2x minus 5 to the third times 2. And then now we just fill it in. So this is the side work. Now we fill it into the product rule formula, which is like this. It's the derivative of the first term, keep the second term the same, plus the first term times the derivative of the second term. So let's fill it in. So derivative of f is 3x squared times g, regular g, which is 2x minus 5 to the 4th, plus f, regular f, x cubed, times the derivative of g, which we found using the chain rule. I'm going to scroll, actually let me just write it below, plus, so it's x cubed times 2x minus 5 all raised to the 3rd power times 2. And again, I don't want to simplify. Too much work. So there's our answer. Let's continue on. Continuing on. Question 10. Let's see what I can do. Let's do this one. Y is equal to 1 plus cosine squared of 7x all raised to the, let's say, the third power. I'm just going to make this up. And here we go. Derivative. I actually noticed two things. It's just a triple composition is what I like to call it, or three things, three parts. And we just basically still apply the chain rule as is. So the chain rule says what's the inside and what's the outside. The inside's here and the outside's here, right? They're kind of like the big picture. So g of x is equal to 1 plus cosine. I'm going to rewrite it in a more easier way. Cosine of 7x squared, and then f is x cubed. That means the derivative of f is 3x squared, and then the derivative of g, we have to use the chain rule here. And the derivative of 1 is 0, so it's just really the derivative of cosine. Oh, this is a quadruple composition. That's what I just realized right here. Let's do some side work instead. This one's a very cool example. Cosine 7x squared. What's that derivative? That derivative, we bring this out, so it's 2 cosine of 7x times the derivative of the inside. So now we have to apply the chain rule again, which is this part. If I could just continue this logic downwards. This is negative sine, and I'm going to plug in a 7 there, because it's the derivative of the inside here. So that's the derivative of the inside, so that's really g prime of x, which is 2 cosine 7x times the derivative of the inside, which is negative sine of 7x, and then times the derivative of the inside, which is negative 7, so I just stick it out at front. And then, let me erase this. This one was a hard one. So then we just plug it in. 3x, or 3 whatever g is, so 1 plus cosine 7x squared. And then multiply by that chain, which is 2 cosine of 7x times negative 7 sine 7x. So that one was a hard problem. I guess you can just go through it really slowly. It's a quadruple composition, and I guess an easier way to think about it, if I have a of b of c of, let's not use c, let's use f. Actually, let's just h, f, g, h, and I. Alright, this is kind of the problem where we set out to do. The derivative is basically a very similar pattern. Alright, find the derivative of the outside, keep the inside the same, and then multiply by the derivative of the inside, keep the inside the same. Multiply by the chain, which is h prime now, and then multiply by I prime. So that's, and then this pattern can actually continue on if you have like 5 composition or 6 or 7. You just keep this pattern going, but that one was a hard one. Let's continue. Okay, so number 11, we have this function, let's see, this one, y is equal to the square root of tangent of 5x, and this is the function we'll be using the chain rule with. So remember that strategy is always helpful to write it in terms of fractional exponent. That's what I'm going to use right now, 1/2. So when I take the derivative, I see that there's going to be an inside function and an outside function here. Let's see, I'll just write the thing. So if the inside is tangent of 5x, that means the derivative of the inside, we will have to use a chain rule for this one, but this one's an actual pretty simple one. And you'll see that it's just the inside is 5x, so the derivative of the inside is 5, and then I'll just find the derivative of the outside. So it's secant squared of 5, keep the same inside, and then do that. And then the outside is x to the 1/2, so that means the derivative is 1/2 x to the negative 1/2. So then its derivative in all is 1/2 x, which we want to keep the same, so tangent of 5x to the negative 1/2, can't forget that one, and then multiply it by 5 secant squared of 5x, and that's the answer. Okay, on to the next one. This is the problem, question 12, and then we just continue. I'm just going to know what the inside and what the outside is, then I'm going to take the derivative, which is y prime is equal to minus, so you bring this out, the outside, and then subtract 1, so it's minus, keep the inside the same, and then minus 2, keep that power rule, and then multiply by the derivative of the inside. Derivative of cosecant is negative cosecant x cotangent of x, and then plus the derivative of cotangent, which is negative cosecant squared of x. So that one was that problem. See, like some of these you can actually do in your head, but not like some of these might not be able to do in your head, but some easy ones maybe you should be able to do in your head a little bit quicker. Let's try to show an example of what you can do in your head. This is a very simple chain rule example that is pretty common, the sine of something t. So the derivative, we can just do it, right? Sine is cosine, keep the inside the same, and then multiply by the derivative of the inside, and I just like to stick that out in front. Another easy example is let's do square root of 3x to find the derivative of this. Remember, we just look at the, I guess the derivative, we should note the derivative of this is 1 over 2 square root of x, so we kind of do that. We do 1 over 2, keep the inside the same, and then multiply by the chain, which is 3. So I guess I can write it as 1, and that's the derivative. So some of these you can actually do in your head. Some easier ones, but like something like this, I would probably have to write it out, or like start thinking about it a little bit more. Something like this, I definitely have to think about much more, so just like a quick aside. Continuing on, let's just go to 15. So this is the last example. Let's do one more to wrap it up. Y is equal to x, x sine of x. So this is a kind of product rule, but it's actually a much larger thing. Let's see, so I rewrite it, x sine of x, 1/2. So we have to apply the product rule to the inner part, so the inner part is equal to, x sine. So that means g prime of x is equal to, so now you apply the product rule. I'm just going to go through this fast. Derivative of the first, keep the second the same. And then keep the first the same, derivative of the second. And then the outside is x to the 1/2. And then that means the derivative of the outside is 1/2 x to the minus 1/2. And then we just fill it in. Minus 1/2 x sine x, and then negative 1/2, and then fill in the sine x plus x cosine. And that's it. That's it for this video.